This video tutorial will explain how to configure and work with high-speed video cameras from IDS. These are the cameras that look similar to the one you see pictured here. They're available as either GigE or USB 3.0 devices. Now the IDS cameras do require some configuration, and one of the first utilities that you'll use is a program called the IDS Camera Manager. This software is provided along with the cameras, and it allows you to configure, in the case of GigE cameras, the IP address and other various settings necessary to operate the cameras successfully within our software. You will see a list of available devices when you first bring up the software. In our case, we only have one camera connected. One of the first things you'll want to do is check the Ethernet Network Service button here. This panel displays the available network adapters inside your computer and allows you to decide whether or not the IDS Ethernet Network Service is running on top of each of these ports or controllers. Normally, you would only want that software to run on top of your physical wired network cards, and only those that are actually going to be involved with the cameras themselves. So as you can see in our configuration, we have one card with the software enabled. The other two cards, notice the little red check here, so our wireless adapter does not have the software enabled. You would click this button down here to turn that on, nor does this other virtual adapter, I should say, here. Okay, so on the physical card with the wired network port, we have enabled the software to run on top of it, and you'll notice we have also assigned a hard-coded IP address. Now, that network address you see here in the software is actually not configured by this software. That is configured using your standard Windows Network and Sharing Center. I'll just show you that briefly here. So here's the Ethernet connection, and under Properties, if you open the TCP/IP4, you'll see that the following IP address has been checked, and we have supplied a hard-coded address 192.168.4.1. We recommend that you use a unique network address for each of your cards. This will help you to easily identify your cameras later on, especially if you have multiple cards in the computer going to multiple cameras. Each card will need to have its own unique IP address. Let me just cancel that. I didn't mean to make a change. Okay. One other setting that you'll want to make note of when working with these GigE cameras is under the Configure button. Here, you will want to enable something called Jumbo Packets. This is under the Advanced tab, Jumbo Frame, I should say. And depending on the network card that you have, there could be different values available to you here. Just set one that's at least 4 kbits. That's as big as you need to go, so at least 4 KB. Setting a larger value doesn't improve performance, so 4K is plenty. So make sure that that is also set on your network adapter. Now, after you've configured your network adapter, you can then plug in the camera, and here in the IDS Camera Manager, you should at least see that the camera is present on the network. Now, the cameras themselves can be configured automatically if you want. You can press the Automatic ETH configuration button, and that will assign an IP address that should work given your network card's configuration. You can also, let's see, give me one moment here. There's also a way to configure the camera manually with an IP address. Let's see. Okay, expert mode, I believe, is what we need to check. If you check expert mode here, that will bring up a manual ETH configuration button. And on this screen, you can literally assign a persistent IP address to the camera which we'll do. For instance, we'll have it recommend one to us. And so it's chosen 4.2. That's fine if you want, or you could change it to something a little different if you choose, like 4.10. And this will now program the camera to live at this IP address all the time. Now, obviously what this means is that the camera will have to be connected to a network adapter that is also on the 192.168.4 network. Okay, so if you plug the cable into a different card that's using a different network address, this camera will not function properly. And this is all good. It's by design that you would put these things at known IP addresses. Okay. Now, one other function we want to talk about is the additional functions button. Here we're going to focus on the setting camera parameter when camera is open, this section of the screen here. This is basically saying whether the camera should initially start up with default settings in terms of its area of interest, its color depth, its quality setting, the shutter speed, all of those kind of things. Or if it should load its values from something called a parameter set. A parameter set is just internal storage within the camera where you can program it to behave in a certain way. And then every time the card or the camera starts up, that's the way it will behave by default. Well, we want to set it that way, so make sure that parameter set is checked here. And you will have to do this on each camera if you have multiple cameras. They will all need to have a unique IP address, and they will all need to have the parameter set enabled under the additional functions. Now there's one other thing you'll have to change for each of your cameras in the case of a multi-camera system. Under the general information button, camera information button, you will need to set something called the camera ID. Camera ID is basically a unique number that must be assigned to each camera so that Microsoft Windows can distinguish one camera from the next. By default, all of the cameras come from the factory set at camera ID 1. So this is fine if you only have one camera on your system, but if you have more than one, make sure that you choose a different camera ID and just assign it in this box here and press OK so that the cameras are numbered in this column here 1, 2, 3, 4, and so on. Okay. So having done that now, let's talk about how we can configure the various camera properties. Remember, these are going to be saved inside the camera. So to do that, we're going to use a utility called the uEye Cockpit. You can get to that software by double-clicking on a camera in this table. So I'll just do that now. And we'll tell it to come up using no profile to start with. Here we see the uEye Cockpit software, and we're accepting live video out of the camera at this time. It's previewing on the screen, and it's using the settings that are currently programmed into the camera. So you'll notice that this camera is running at 1280 by 720, and it's attempting to do around 60 frames per second. You can also see, though, that it's not keeping up because we're getting failures during the transfer. So we might need to slow this camera down a little bit or reduce its area of interest or something to that effect. How do we change these settings then? Under the uEye menu, choose Properties. Now this will open up all of the properties that the camera is capable of working with or changing. The very first panel you see, Camera, on the Camera tab, has the value setting for pixel clock. This is very important. The pixel clock setting determines how fast the sensor in the camera is being scanned. The faster that you set the pixel clock, the faster the frame rate of the camera, up until you reach some maximum where you're going faster than the camera can keep up with or faster than your system can keep up with. When that happens, you'll notice that this top number becomes red in color, that indicates that you're exceeding the performance capabilities of the system. So just back it down until you get it into a black color, and then you're going to see a certain speed here and your frame rate setting, a range that will indicate the top speed the camera can perform at given its current image size and so forth. So we'll stay with this for now. 60 frames per second is going to be our target. We can also just type that in here if we want to. Okay. Now let's take a look at some of the other values we have. For instance, on the size panel, there is the ability to configure different size images from the camera. Now this will be different for each different type of camera that you're working with. In this case, the camera can go up to a maximum of 1280 by 1024 on the image size. But we can also reduce this. For instance, if we lower it to 960 by 480, and then we say show only the area of interest. Okay, we now will have a much faster frame rate because we're using a smaller area of the lens. We're getting a 960 by 480 image at about 86 frames per second with an occasional drop here or there. You can play with these values to come up with whatever settings you want. Give you a typical example would be to run the camera at 1280 by 720 at 60 frames per second. Another idea is to set the camera, let's say you're using the 720p setting like this. If you turn on scalar mode, what this will do is reduce the image size while still using the full range of the camera's sensor. The net effect is that you still get a very high quality image, but you can get the speed to increase even further as you reduce that size. You can see down here at the bottom the frame rate is going up as we lower the image size, but because we're using scaling mode, we're still seeing the entire area of the scene. Now let me show you the difference between scalar mode and simply using a smaller area of interest. So if I take the width setting and I bring it down, and I take the height and I bring it down, you'll see that what happens to the image is we see less and less of it. Okay, because we're telling the camera not to use the whole lens or the whole image sensor area. We're just using a portion of it. Now this will also speed up the performance, but the side effect is that you don't see the entire picture. Now that might be fine for many circumstances, but if it's not, then you can use one of these standard settings with scaling to get smaller pictures at higher speeds while still viewing the entire scene. Okay, so that's what that's all about. Another setting that you'll want to pay attention to on these cameras is the format setting. By default, these cameras have this value here. The debayering quality is set to normal. And I want you to notice, if you look at the picture, when I change it from normal to high, I'm going to do that now, you see that you get a clearer looking image. So you want to use high quality setting for the image format. Okay, by default it's going to be at normal quality. Just come in here and check that to high quality to get this clearer picture. And there's so many other things you can change. Another one that's important has to do with automatic exposure and gain. So we do recommend that you use these values. This will cause the camera to automatically adjust itself based on the lighting that you have in your room to maintain a certain brightness level by changing either the gain or the shutter speed so as to get the best possible picture with the available lighting that you have. So you set both of these values here, and then you adjust the brightness reference to tell the camera how bright of a picture are you willing to accept. Now, what does this have? What effect does this have by darkening or brightening the picture? Well, it's going to change the shutter speed that the camera is running at. So Right now, you'll see the camera is running with a 10 millisecond shutter as its maximum value. And let's take a look at what the shutter is actually doing. You can see that up here at the top. It's running at 0.048 milliseconds right now to produce this image, which is really quite fast. A 1 millisecond speed is adequate to eliminate blurring in most filming that you'll do. So I can bring this brightness level up considerably because I have the camera looking out into a bright sunny environment, and once it settles itself out on the speed it's going to run at, you can get the kind of image that you're looking for. Now if I bring this camera indoors, I'm going to now point it more into the office. What you're going to see is that the shutter speed has to be slowed down considerably to maintain the same level of brightness. So that's as it's working itself out right now, but you'll notice in general the shutter speed is going to be now running 4 or 5 milliseconds in this indoor view to accomplish the same level of brightness. Okay, well, if you're willing to take a slightly darker image, you could lower this brightness reference down, which will have the effect of speeding the shutter up. Just give it a second to sort itself out. Okay, now here we have the same interior view coming into focus. The shutter speed will probably come out somewhere around 1 or 2 milliseconds in this case. So we'll leave that camera to sort itself out later, but we'll keep it pointing outside for now. Okay, so yeah, as you can see, you have all these settings you can play with in the camera under the uEye cockpit. Once you've configured the camera to a certain setting, you'll want to save that as a parameter set inside the camera. This is how you tell the camera, remember these settings and use them from now on. So save parameters, and then you say to parameter set. Okay, and now, because if you recall over here in the uEye cockpit, we had told the camera to start from its parameter set and not from its default values. The camera will come up in this mode 784 by 442, running at 90 frames per second, 93 actually, when we bring it up into our MotionView software. So let's do that now. We'll close down the uEye Cockpit software. We can close down the IDS Camera Manager as well. And we'll start our software, MotionView. Okay, here we are in MotionView, so we'll go to the Configure Cams screen, and we will choose the uEye camera. As you can see, I have quite a few cameras configured on this computer. Here's the uEye camera, or the IDS camera we've been working with. So we'll choose it. And you'll notice it comes up at the 782 or 784 by 442 video size, just like we told it to do previously. The frame rate for MotionView has to be selected here, so we didn't set that earlier. We'll just go ahead and change it to 90 frames per second. Okay, we're reconnected now, and we'll just go back and do a short recording. Alright, and now we'll take a quick look at the information. Control-I brings up this little screen for you, by the way. And you can see there it's 90 frames per second at 784 by 442. Okay, so that's one way to set the default values for your uEye cameras. There is another way to work with, let me just say, you can do that process we just showed you using the uEye cockpit to save specific parameters into any single camera, and that camera will come up working the way you have it configured. If you want to set multiple cameras all to the same values, which is quite typical, we do have support for that here in the software using the IDS settings button. The IDS settings button is a special utility that will come up inside MotionView and allow you to access most, if not all, of the same settings that you saw over in the uEye Cockpit software. So here's our pixel clock, here's our image gain and darkness levels, here's control over the area of interest, whether or not there's binning happening, white balance, exposure and gain. There's the brightness, reference that we had before, and so on and so forth. You do not have control over the quality setting, so you do want to make that one happen in the uEye Cockpit software. But you can change a number of these values here, and then when you update the camera with those settings, you can then choose Update All Identical Cameras, and it will load the exact same values into all IDS cameras that are found on your system. So assuming that they're all the same type, in terms of sensor size and so forth, same model number camera, they will all receive the exact same characteristics. This is a little easier than you having to open each one individually in the uEye Cockpit software and program each one of them that way. Okay, so that's how you do that in our software. I hope this information has proven helpful. We'll continue with additional tutorials in the future. Thank you.